Hi guys, welcome to another lesson of Algebra 2. This lesson is Quadratics 3.2 on page 56 of your packet. We are going to be learning how to factor trinomials. But first, I would like to remind you that the first step in factoring is to factor out the greatest common factor, or we call that the GCF. This is often a forgotten step in many problems. The GCF will be 1, and thus there is nothing to factor up. So let's try to factor something that is not so complicated. Let's start with 3x squared minus 9x. And again, the first step is we need to find the GCF, the greatest common factor. What is common between the number 3 and the number 9? Okay, I think what's common between them is 3. They both have a 3, correct? And then for the variable x squared and x, they both share an x. And because they both share an x, let's put the 3x on the outside because they share that. And then we'll kind of divide each term by 3x. So 3x squared divided by 3x, that is just an x. Correct? And then we have a negative 9x divided by 3x. The x's are canceled, so that's left with negative 3. Therefore, the factored form of 3x squared minus 9x is 3x times x minus 3. That's it. Okay, not that bad, right? So let's move on. Let's have more examples here. We have 10x squared plus 15x. So I think we have 5 in common. And x is also in common. If you notice, we have 5x on the outside. And then we have divide each of them by 5x. So 10x squared divide by 5x. That's a 2x. And then we have 15x. The x is canceled. That's a plus 3. So we have 5x times 2x plus 3, where the 5x is the GCF. So GCF is 5x. All right. Over here we have 8 and 28. What is the greatest common factor? Of course, 2 is common between 8 and 28, but we're looking for the greatest common factor, and it looks like that's a 4x. Okay, so we'll put 4x, and then we do 8x squared divided by 4x, that's a 2x. Negative 28 divided by 4, you get a 7. So you have a 4x times 2x minus 7 with a GCF of 4x. Okay, what about number 2? It looks like the 18 doesn't have an x at this time. So it looks like x wouldn't be common. What about 2? So let's put 2 on the outside. What goes inside? So we'll divide each of them by 2. So you have a 2x squared divided by 2. That's an x squared minus 5x and then minus 9. So over here is what you call your factored form. Okay, but if you notice, this one is still squared. So we still need to factor all of these, the ones that are inside. But that's on the next page. For now, we are only focused on finding the greatest common factor. All right, on this page. So this one is, they have a 3 in common. Would you agree? So that's it. 3 closed. Let's have 3x squared divided by 3. That's an x squared. Negative 12 divided by 3. That's a negative 4x minus 7. So our GCF is a positive 3. Okay, cool. Now pause this video and I would like you to go on page 64 and you're going to answer homework problem number 1 and number 2. Again, you're only focusing on numbers 1 and 2 because the rest of the problems are these are bisection. So for now, go to page 64 and then answer number 1 and 2. When you're done, come back to the video and learn how to do the rest of the problems. Okay, now I'm going to have to go over here. I'm going to skip some more. We have here we're gonna have to factor completely. Example number 2, okay? You have to factor completely and check your solution by multiplying the result together. Now, you know how in 3.1 you were trying to multiply two binomials. So you have like, let's say for example, this is just a random problem, right? So you, for example, you have an x plus 5 and a 3 and an x plus 3. Okay, so you have a factor, the factored form x plus 5 and x plus 3, and you wanted to, let's see, you want to put them together. You're going to make them a trinomial. So you're gonna multiply this. You use FOIL, you use the box method, or what else did you guys learn? Or maybe you call it the rainbow method. So you will multiply each of these, right? And we learned that one on 3.1. So again, this is just a random example. So you have an x squared plus 3x plus 5x plus 15. And then you have x squared plus 15. And you see how these two right here, right? So you have a 3x and a 5x. And so you're going to do plus 8x, right? And so the x plus 5 and x plus 6 is a trinomial that resolves into x squared plus 8x plus 15. And so what we're doing today is we're doing a reverse process where we have the trinomial and we want to go back to the factored form. Okay? Does that make sense? So here is what we're going to do. There. First step is you have to figure out if there is a greatest common factor. So let's say on the previous page, I did divided each of them by 2, divided by 3, right? Because I tried to find a common factor. But in here, in number 2, it looks like there's no common. Aside from 1, of course, right? What about letter B? Is letter B no common also? So letter B, C, D, no common. Now, there are a lot of ways on how to factor trinomials. There's one that is called the X method, which is really, really easy, but I'm not going to be teaching that in here because I'm preparing you for something that is going to be on the next page that it might be harder if you learn it on the X method. So I'm going to be teaching you something called factoring by grouping. And a lot of you might be familiar with it already from your previous Algebra 1 teacher. So let's see. So if you have an x squared minus 7x plus 12, first is I'm going to multiply my a value and my c value. So when I use the a value, that's the number before the x squared, right? So the number before the x squared is a 1, right? So that's 1 times 12. So that's a 12. Okay, so, and then you're going to find out two numbers that when you multiply, you'll get a 12. What are the number that you multiply, you get a 12? That would be 6 and 2. That's a positive 12. That's a 3 and a 4. That's a positive 12. But then you need to also figure out that you multiply it. Let me see. Let me change the color. Okay, wrong way. So you multiply it to get a 12, but when you add it, you get a negative 7. So right now, both of my pairs, all of them are 12, but none of them are negative 7. So in order for me to make that changes, but why don't I make them both negative? Now, these two numbers, when you multiply them, you get a 12. When you add them, you get a negative 7. So this is the perfect pair for our trinomial. So I'm going to put it as x squared over here, right? Then minus 3x minus 4x plus 12. If you notice, I am not changing the problem. I'm just splitting the negative 7 into two parts. Does that make sense? Okay, now I'm going to group them. Okay, so I'm going to change the color. I'm going to group the x squared and the 3x. And then on a separate side, I'm going to group the 4x and the 12. I know there are so many ways to do this, and you probably already know what the answer is, but I'm preparing you for something difficult later, and that's why I'm introducing this one in here already. So we have x squared minus 3x minus 4x. I'm going to group the x squared minus 3x. So in here, both of them has an x. So that's an x squared divided by x. You have an x. Negative 3x divided by x is a minus 3. And then for the next part, both of them has a negative 4. So that is a negative 4. That is x minus x minus 3. And because x minus 3 is already common, I'll just write 1x minus 3, and I have an x minus 4. So the the factored form of x squared minus 7x plus 12 is x minus 4 and x minus 3. Okay, moving on, I have negative x squared minus 2x minus 35. Later on, I'm going to do a shortcut, okay? I'm not going to be doing this part over here. After we do maybe two examples, I'm going to skip doing this part. So I'll have x squared minus 2x minus 35. So first I do a times c. My a right now is a 1 and my c is negative 35. So that's a negative 35. A number that when you multiply, you'll get negative 35. When you add, you get negative 2. A number that when you multiply, you get negative 35. When you add, you get negative 2. What do you think that is? That is a 7 and, oops, it's not writing, 7 and a 5. And because we have a negative 2 in the middle, the bigger number must be the negative. So let's put x squared minus 7x plus 5x minus 35. And let's see, is 7x minus 5x negative 2x? All right, that's confirmed. Now I'm going to group them. I'm going to group these two first, and then I'm going to group these two after. So what's common between x squared and negative 7x? Is that x is common? So we have x minus 7. What about 5x and 35? Is 5 common? So that's an x minus 7, right? 5, because when I do over here, 5 times x is 5x. 5 times negative 7 is negative 35. Therefore, my factored form is, I'm going to group these two together. X plus 5, x minus 7. And done. Okay, two more problems. We have x squared plus 5x minus 24. So multiply a and c. That is a negative 24. So what gives negative 24 when you multiply and then it gives you a 5? A positive 5 when you add them. Any idea? You can use 12 is 12 times 2 is 12 times 2 is 24, right? But does that give you 5? It will not give you a 5. So that's not a perfect pair. What about we try 8 and 3? Yeah? So 8 and 3 is not a negative 24. Which one should be negative? The negative 8, the 8, or the 3? So in order for us to identify which one should be negative or which one should be positive, we look at the positive in there. So since it's a positive 5, meaning the bigger number must be the positive. So I have x squared plus 8x minus 3x minus 24. And let me verify first. Is these two together a positive 5x? Okay. And now again, let's group them. I will group these two, and then I'll group these two right here. Does that make sense, you guys? So what's common between x squared and 8x? X is common. That is x plus 8. Collect, miss, I don't get that. So if you do x times x, would you get an x squared? If you do x times 8, would you get 8x? So I didn't try to change the problem. I only factored the problem. Okay, and then I'll go with negative 3x minus 24. I think negative 3 would be common. Not 3x because the 24 doesn't have an x. So you have a negative 3. That is x. What's negative 24 divided by negative 3? Because negative 3 is common. Does that, I hope that is making sense. Okay? So you're gonna have an plus 8. Because again, you're dividing both of them by negative 3. So divide this by negative 3, you'll get an x. Divide that by negative 3, you'll get a positive 8. So you have x plus 8 in common. So you're just going to put that together, and then you put the x minus 3 together. So the common factor would be x minus 3 and x plus 8. Alrighty. Does that make sense? Okay, letter D is kind of the same. Let me do letter F for you guys. Okay, so we have 1, 2, 3 examples already. Let's do letter F because it looks like letter F is something different. So is there a common between 545 and 90? And I think there is, yeah? That is 5 in common. So I'm going to put a 5 in there. That's x squared plus 9x plus 18, isn't it? And then again, I know that one of my answers is going to be a 5, so let's put 5 in there already in the final answer. And we're going to concentrate on this one inside. Okay, let's start with multiplying. What do we multiply? X and, oh, sorry, A and 18. Our A is 1, so 1 times 18. So 18. What gives you 18 when you multiply and gives you 9 when you add? Oh, that's so easy, yeah? 6 and 3. So now I'm going to keep putting the 5, but you technically can ignore the 5 for now. So you have x squared plus 6x plus 3x. Is that a 9? 6 plus 3 is 9x plus 18. And then we'll group them. Group the, I like yellow. Group these two together. And then let's put a blue. And then group that together. So we have 5. What's common between x squared and 6x? That is x is common. Hold on. Let me put there. I'm gonna, oh, I am aware of the 5, okay? But I'm just gonna leave it for now. I'm not gonna add it so it doesn't confuse you. Let leave the 5 in for now. So I have a 5 in there. X is common, right? So x squared plus 6, that's x plus 6. Because let's verify. X times x is x squared, that's good. X times 6 is 6x, that's good. And then moving on, we have plus 3. So we divide this by 3, divide this by 3. What's 3x divided by 3? That's an x. What's 18 divided by 3? That's a 6. And remember, our goal is to get these two common in the parentheses. And we already have. So our final answer is x plus 3, x plus 6, and don't forget the 5 on the outside. So I'll just put x plus 6. There you go. You guys need another example for that? Okay, last one example for this then. Letter G. Letter G, they have all what in common? A 3? So 3, 3, 3. So I know my final answer has a 3 on the outside. So 3, we have x squared minus, that's 12, right? And then you have, oops, wrong, 20. And then you're going to multiply your A value and your C value. That is a 20. 20 is 10 and 2, but that doesn't give us a negative 12. What about we make them both negative? Would that, is that good? So negative 10 times negative 2 is negative 20. Sorry, it's positive 20. And then negative 10 plus negative 2 is a negative 12. So it fits. So we have, I'm going to again leave the 3 on its own for now. Okay, but of course we're going to put that back later. And I already have that there on my final answer anyway. So I have, where am I? X squared minus 10x minus 2x plus 20. Let's verify. You got x squared, you got 20. And these together will give you a negative 20. Okay, so you have, again, we're going to group them. Group this together. And then I'm going to group those two together. I will then end up with x minus 10. Let's verify. X times x is x squared. X times negative 10 is negative 10x. And then we have a negative 2x in common. Negative 2x divided by negative 2x. Oh, sorry, not negative 2x, just a negative 2. Because the 20 doesn't have an x, so we have negative 2x divided by negative 2 is x. Positive 20 divided by negative 2 is a minus 10. Do you guys notice this? It always comes back, yeah. Whatever that's in here, it always comes back in there. Same thing for here. You see that? So later on, when you get used to it, you're like, oh, okay, I already know it's gonna be x minus 10. Okay, and then let's combine these two together. We have x minus 2, x minus 10, and don't forget, we have a, oh, I always do that. We have a 3 on the outside. Yep, this the GCF 3. And so this is x minus 2, x minus 10. Yay. Okay, and I think after going through how many examples? Oh, that's a lot of examples. 1, 2, 3, 4, 5 examples. I hope after doing 5 examples, you're now able to answer. Now you can pause the video and answer page 64, numbers 3 to 10. Okay? Alrighty. Let's good to go. Moving on. We now have, let me go to number 3. Number 3 is to factor completely. Same thing, yeah, factor completely. Check your solution by multiplying the result together. So, let's analyze this. Is there a common factor between 2, 17, and 21? It doesn't look like, yeah. So we can just continue on making sure that, because again, that's always the first thing you do. you have to figure out if there is a greatest common factor. But because there isn't a greatest common factor in here, we're just gonna move on to multiply A and C. So A times C, 2 times 21 is 42. Okay, I did say that I'm not gonna do this again, but I keep doing it. So 42, what are the two numbers that you multiply? For now, I'm gonna keep doing it. So your brain could practice on how to find numbers that you multiply, you get this, when you add, you get this. So 42, two numbers that when you multiply, you'll get 42. When you add, you get negative 17. And of course, 42 divided by 2, that's 21 and 2, right? But will 21 and 2 gives you negative 17? It doesn't look like. So that's a wrong idea there. What about 14 and 3? Is that a 42? Yeah, that is a 42. But 14 and 3 will not give you 42. It will give you 42, I mean, but it will not give you negative 17. So why don't we make them both negative? Will that give us negative 17? Yes, it'll give us positive 42 and it will give us negative 17. Okay, so let's see. So you have a 2x squared. I just copy the problem. And remember, we're splitting the negative 17. So you have 14x minus plus 21. So this 2 right here, oh, sorry. This 2 right here is negative 17, split into two parts. Now, we are gonna group them. So I'm gonna group this part, and I'm gonna group this part here. Okay? What's common between 2x squared and negative 14? Is 2x common? Let me put that in red. So is 2x common? And so what's 2x squared divided by 2x? Is that an x? What is negative 14 divided by 2x? Negative 14x divided by 2x. Is that a negative 7? Okay, moving on. I'm going to be on the blue section. What is common between negative 3x and 21? Is that a negative 3? Not 3x, yeah, because 21 doesn't have an x. And so you're going to go 3x divided by negative 3. That is x. And then you do 21 divided by negative 3. That's a negative 7. So your final answer is 2x minus 3 and x minus 7. And done. All right, moving on. Number 2. We have, is there anything in common? 2, 3, and 20. No. So let's proceed to A times C. That is negative 20. What's negative 20, by the way? That is 10 and 2. It doesn't give us a 3. What about 5 and 4? Nah, it doesn't give us a negative 3. Yeah? Oh, why am I putting 20? Oops. Rewind. I meant negative 40. Okay? So we have a negative 40, 20 times 2. And so what do we multiply to give us 3? So if we do 20 and 2, or even if we do 20 and negative 2, they're negative 40, but that does not give us negative 3, right? What about we do negative 8 and 5? Is that negative 40? Yes. Is that negative 3? Yes. So we're gonna go on to x squared. Let's put these two pairs together. Negative 8x plus 5x minus 20. And again, the 3x is gone because we split this into two parts. Okay, let's highlight them so we can do them by group. So let's solve this together, and then we'll solve these together. Okay, what's common between 2x squared and negative 8x? Is 2x common? What do you guys think? So you're gonna do this negative 2x squared divided by 2x, that is x. And then you do negative 8x divided by 2x, that's a negative 4. Do you guys agree? And then I have what's common between 5x and negative 20. I think that would be a 5 is common. Then you do 5x divided by 5. You got a 5. Oh, you get an x. And then you do negative 20 divided by 5. That is a negative 4. So let's combine those two. 2x plus 5, x minus 4. So that is your final answer. Okay, do you guys need more example? Okay, let's do maybe one, two more. Okay, we have, what is that one? 30. So 30, 10 times 3. It's not because it's not going to give us negative 11. What about 15 and 2? Nope, because that's not going to give us negative 11. What about 6 and 5? Nope, it'll give us 30, but it doesn't give us negative 11. Oh, what if negative 6 and negative 5? Would that give us negative 11? Yes, it will. So we'll do 3x squared minus 6x minus 5x plus 10. And again, we will factor by group. So factor this and then factor this. What is common between 3x squared and negative 6x? We have a 3x in common. We have, what is that? X minus 2. Let's verify. 3x times x is dx squared. Negative 2 times dx is a negative 6x. So that is perfectly fine. And then this is negative 5. And that is x minus 2. Let's verify. This multiplied together gives you negative 5x. This multiplied together gives you a positive 10. So our answer is 3x minus 5, x minus 2. Boom. Done. Okay. One more. One more. Last example. Okay, last example. I know it's a lot, right? I have 12 and 5. Negative 12 and 5. What is that? Negative 60. Okay, so we have, that's a lot of number. 60 is a very famous. So 60, that's 30 and 2. We have, but that doesn't give us 11, right? We can also do 20 and 3. That doesn't give us 11 either. Do you guys know what I'm trying to do here? I'm trying to okay, what is the perfect pair? We have 15 and negative 4, right? Because 15 times negative 4 is negative 60, and then 15 plus negative 4 is 11. So we have 5x squared plus 15x minus 4x minus 12. That's kind of a lot. Okay, let's factor them by group. There you go. So I have, what's common? Is it 5x is common? So that gives us x plus 3. Let's verify. 5x times x is 5x squared. 5x times 3 is 15x. Good. We are good to go. Moving on. We have a negative 4x plus 3. Let's verify. Negative 4 times x is negative 4x. Negative 4 times 3 is a negative 12. Combine these two, you have 5x minus 4 and an x plus 3. And done. Okay? So, I think you are ready to do page 65 on the homework page, numbers 11 to 14. So if you go to page 65, numbers 11 to 14, you will see this part of the problem. Okay, and I would like you to pause the video and do numbers 11 to 14 on page 65 and 66. And then last lesson for factoring trinomials is what we call difference of squares. Now, this part is like the easiest part of factoring, but it could get a little confusing. So follow me along in here. We have there are some trinomials in the form of ax squared plus bx plus c that actually look like binomials when b is equal to 0. So when this is 0 right here. While the x or x box method can still be used, there is a faster way to factor these if you notice a certain structure. So you still can use the I didn't teach the Xbox method, but I did the factoring by grouping. You still can use factoring by grouping when b is equal to 0, but there is an easier way. Okay, and this is called the difference of squares. A binomial of the form a squared minus b squared is called a difference of squares. Note that the first term must be something squared, like x squared, or a squared, c squared, or 25 because 25 is squared because that's a 5 squared. The second term must be something squared like this, and the sign in the middle must be subtraction. It couldn't be a positive in there. The name difference of squares should make sense now, right? You subtract the squares. Does that make sense? A binomial that is in this form factors according to this formula. A squared minus b squared is equal to a plus b, a minus b. And let's see what that means. For example, number 4, factor 2x squared minus 50. You have to check your solution by multiplying the result together. The first step of factoring, as usual, is to find the GCF of this term. So the GCF is 2. You know how they have 2 in common? Let me put that in there. 2, 2. Okay, hold on in there. We're almost done, guys. So the GCF of this term is 2. Factoring this out, we have 2x squared minus 50. Because you know how we did that earlier, yeah? So 2 is common, so we have x squared, 50 divided by 2 is 25. So we have 2 times x squared minus 25. Okay, let's move on. Let's concentrate only on the part in parentheses. So concentrate only on the ones that are inside the parentheses. Note that x squared, this part, is x squared or x times x, correct? And notice that the 25 is a 5 squared. Is that making sense, you guys? So like if I do x squared, that's x times x. If I do 25, that's 5 times 5. Yeah, that makes sense, right? Okay, moving on. We have, thus, when looking at the a squared minus b squared structure, we see that the a is equal to x and the b is equal to 5. Therefore, the binomial must factor into x plus 5 and x minus 5. Including the GCF, we obtain our final answer as 2. So now we have 2, oops, sorry. Now we have 2x squared minus 25. Following the formula over here, that becomes 1x plus and 1 minus. And since 25 factors into 5 and 5, they both go in here. And so this is our final answer. Is that making sense? Okay, let's go example number 5. What about we factor 4x squared and 81? Is there any common between the two of them? So the 2 goes into the 4, but the 2 doesn't go 81. So we cannot do a GCF anymore, yeah? The first step on factoring GCF of this term is 1, so there's nothing to factor out initially. So let's just proceed on. The note that 4x squared is technically 2x times 2x, isn't it? So where do I write that down? So 4x squared is 2x times 2x. And then note that 81 is 9 times 9. Does that make sense? Okay, and then we do, thus, when looking at a squared minus b squared structure, we see that the a, this is our a value, this is our b value. And remember the formula is a plus b and a minus b. So technically what that means is I'm going to combine both of them, but one is a minus and one is a plus. And that is the answer. Okay, let's try. So we have x squared in 64. So x squared is x times x. 64 is 8 times 8. Therefore, this is x minus 8 and x plus 8. Done deal. Let's move on to 9x squared minus 16. Can they still be factored out? 9 divided by 3, 16 divided by 3 doesn't work. So it couldn't be factored out. So we have 9x squared, that's a 3x times 3x. 16 is 4 times 4. Therefore, this is, what do you guys think? 3x plus 4 and minus 4. Okay, we always have to be opposite sign. All right, what about this one? 49x squared is 7x times 7x. 25 is 5 times 5. So this is 7x minus 7x plus 5. Done. Next, we have 5x squared minus, they have something in common. They have a GCF of 5. So let's divide that by 5 first. You have a 5 on the outside. You have x squared minus 4. Okay, and we leave 5 alone. Just leave 5 alone. We have x squared equals x times x. 4 equals 2 times 2. So we have x plus 2, x minus 2. Done. Next, should I continue? Let's just continue all of this. We have 18 and 2. 18 and 8, and they both factor GCF by 2. So you have 2 on the outside, 9x squared minus 4. Am I correct? Yep. So 9x squared is equal to 3x times 3x. 4 is equal to 2 times 2. So this is 3x minus 2, 3x plus 2. And it doesn't matter which one you write first. You can write 3x plus 2 and then 3x minus 2. It doesn't matter. Okay, 32 and 18, they have 2 in common. So we have 32 divided by 2, we have 16x squared minus 9. isn't it? So 16x squared is 4x times 4x. 9 is 3 times 3. So let's say 4x minus 3, 4x plus 3. And don't forget to put our little friend positive 2 in there. So 2, 4x minus 3, 4x plus 3. Okay? And I think you are now super ready to answer page 65, numbers 15 to 18. And that's the end of the homework. Thank you guys, and I appreciate your patience. And thank you for pausing the video, doing the work, pausing the video, and then doing the work again. I will let me know if you have any questions, and I will see you on the next lesson. Bye.